Hello class and welcome to another physics lesson. In this video lesson, we're going to start off with chapter 20 and this chapter is all about practical electricity. So what can you expect in this chapter? So this chapter explains how electricity is used at homes or at buildings and so on, and the dangers of electricity and also some of the ways that we can safely use electricity at homes and in buildings. We're going to cover the first part of this chapter, and this first part talks about the usage of electricity. So we're going to look at the usage of electricity in three areas: heating, lighting, and also in moving things, or in other words, motors. So the first use of electricity that we will look at is in heating. So we use electricity to heat up things, to heat up food, to heat up our homes, and also to heat up our water. So thermal energy is essential in our daily lives. We use it to boil water, iron clothes, cook food, and even keep ourselves warm. Now, the main component that we use to convert electrical energy into heat energy is this thing called the heating element. And the heating element is basically a coil that you can find inside the heating appliance. For example, this cooker here, you have this coil here, and that's the heating element. For kettles, you can open the kettle lid and see inside. At the bottom of the inside of the kettle, you can see another coil, and that's the heating element. For your ironing appliance, inside there is also a heating element, which is also this coil here, right? So the heating elements used in kettles, irons, ovens, and heaters are usually made out of nichrome. Now, why nichrome specifically? This is because it has a high resistance. It has high resistivity, and therefore it has the ability to withstand high temperature without melting. So why is it important for nichrome to have high resistivity and also be able to withstand high temperature? So the second part is quite obvious. Of course, nichrome will be used to heat up things. That's where heat is generated. Therefore, it should be able to withstand high temperatures without melting. Now, the first point here, which is high resistivity, might not be obvious, but if you remember from our previous lesson, whenever anything that has a high resistance, so anything that has a large resistance, when there is a large current passing through it, it will increase the temperature of that object or that component. So this is the basis of nichrome as a heating element. Basically, you have nichrome, which has high resistance. You pass a current through it, and when the current is passing through the nichrome, it will generate a lot of heat. It will heat up, there will be high temperature, it will generate a lot of heat, and that's how nichrome heats up the thing that we want to heat. Let's take, for example, the kettle. In an electric kettle, thermal energy is generated when electric current passes through the heating element. Then what's going to happen is water surrounding the heating element will be heated up by conduction and convection. And this is explained in the previous chapter, which is a chapter about transfer of heat. Notice that the heating elements are usually coiled up. This is to increase the length of the heating element. So a long heating element will have a high resistance. So we pick nichrome because it's a material with high resistivity. And so we want a component that has as large of a resistance as we can. And therefore, another way for us to increase the resistance of a component is by increasing the length. Okay. So if we make the length longer and then coil it up just to save space, that way we can have a high resistance. So whenever there is a current going through it, we can have high temperatures. The component will heat up and then produce a lot of heat. Now, this is what I explained to you, and we're going to go a bit detail in this slide here. How is heat generated in heating elements or wires? Or in other words, why, when you have a wire that has a high resistance and there is a current passing through it, heat is produced. The reason is when electrons pass through metal wires, they give some of their energy to the atoms in the wire and make them vibrate more. so that the wires get hotter. All right, so it's just mostly about collisions and passing through energy. So if an electron hits or collides with another particle inside the wire, it will transfer its energy to the particle, and that particle will be more energetic and will vibrate more. And because that particle has more energy, so the substance gets hotter. Okay, because the particles of that substance heats up more from the electrons moving inside that substance. For the same current flowing in a circuit, the greater the resistance, the hotter it becomes. Now we're going to talk about the second use of electricity, which is lighting. Now, when we're talking about lighting, the number one electrical appliance that we use to light up our house or our shops or any buildings is the filament lamp. So let's look at how the filament lamp is designed, how it works. So the filament lamp is made up of a lot of different parts, but the most important part that we will talk about is the filament itself. So a filament is basically this thin coil piece of wire here. This is the filament of the lamp, and it is made out of tungsten, which is a type of metal. The filament, which is made from tungsten, are often used in light bulbs. They are so thin that they have a very high resistance. So remember, if you have a thin wire, if the cross-sectional area of a wire is small, in other words, is thin, then you will have a large resistance. Okay, so this filament is not only thin, it's also very long. It has a long length and it's coiled up in this manner to save space, and that will also increase its resistance. So this filament has very high resistance. So if you pass a current through this very high resistance tungsten filament, it will become hot. It will become so hot that it will glow. So if you have seen how a blacksmith forges like swords or any type of metallic equipment, you will see the metal of that blacksmith heats up and produces a red glow. For the filament bulb, it is the same concept. You have a metal tungsten filament, it gets so hot that it glows and it gives off an orange or yellow or white glow. And that's where the light comes from. The light comes from a very hot tungsten filament. The glass bulb is usually inserted with an inert gas. So inside the bulb here is filled with an inert gas such as argon, xenon, nitrogen, or neon. The reason why we put in an inert gas is to prevent the tungsten from getting burned at high temperatures. Now imagine if you put in oxygen, which is a very reactive gas, inside the bulb. Now the tungsten filament is very hot and you have oxygen inside the bulb. What that's going to do is that's going to start off a reaction and it will probably burn the rest of the bulb or it will probably blow up the bulb. That's why, just to be safe, we don't put in any reactive gases inside the filament. So we just put in inert gases so that we can avoid any sort of burns, any sort of explosions, or any sort of damage that can happen to the bulb. Now, another piece of appliance that we use to light up our houses is the fluorescent lamp. So this is a more modern design. Fluorescent lamps are more efficient. That means they use less energy and therefore they can last for a longer amount of time. So they last for about 3,000 hours compared to 1,000 hours for the filament lamps. They cost slightly more, so they're expensive, but use less energy than filament lamps. Thus, in the long term, they are more economical. They save more of your money, save more energy. So how does the fluorescent lamp work? The fluorescent lamp uses two electrodes to produce light. So you probably have a negative terminal here and a positive terminal here. So the electrons So you turn it on, so the electrons will flow from the negative to the positive. And inside the fluorescent lamp, you have mercury vapor. So this is the old style fluorescent lamp. In modern fluorescent lamp, they'll probably use a safer compound other than mercury, because you remember mercury can be quite poisonous. But back in the old days, we use mercury. So when you have electrons passing through mercury, that will produce electroviolet light. Okay, so by passing electric charges or electrons between two electrodes and through the mercury vapor in the tube, this will emit UV light, electroviolet light. And then the electroviolet light that is produced by the mercury atoms will hit the phosphor coating. So there is a layer of phosphor on the walls of the fluorescent lamp. And when UV light hits that phosphor coating, that will produce visible light. Okay, so they will produce white light or orange light or blue light depending on the fluorescent lamp. Okay, so that's how a fluorescent lamp works. Now here's a comparison between the two. You can have a read of this on your own. So you can pause this video, read it on your own. It's actually quite straightforward. So this is the advantages and disadvantages between the filament lamp and the fluorescent lamp. The final part we're going to talk about in this video lesson is electric motors. So what are these things? An electric motor changes electrical energy into kinetic energy. So most appliances that has some type of motion or some type of movement use motors in order to help them move. Okay, so this is what the inside of a motor looks like. So a motor does a sort of like a rotating motion. Now we use electric motors in a lot of different appliances. The washing machine, the inside of the washing machine rotates, and that's because there is a motor inside. The blender has a motor that helps the blades to rotate around. And then even fans are powered by motors so that it can turn. The air from air conditioners are powered by motors, sewing machine, lawnmowers, etc. So anything that needs rotating, or any type of movement, usually we use motors to make that possible. All right. So to summarize what we gone through, so here are the important things that you need to take away from this video lesson for your O-level exams. Make sure you understand how the heating element works. The heating element is made out of nichrome, and nichrome has high resistivity. Whenever you have a high resistance and you have a current passing through it, there's a lot of current passing through it, that will cause the temperature to increase and therefore produce heat energy, and therefore you can heat up things. So make sure you understand how that works. And then make sure you understand why, when there's current passing through a wire or a heating element, heat is produced. This is because when the electrons are passing through the metal wires, they hit the atoms, they collide with the atoms, and when they collide with the atoms, they transfer some of their energy to these atoms. And these atoms will become more energetic, and they vibrate more, and therefore the substance or the wire of these atoms will get hotter. When it comes to lighting, make sure you know how the filament works. It's the same concept as the heating element. The filament is made from a high resistance material, and this is usually tungsten. Tungsten has high resistance. When you pass a current through it, there will be a large increase in temperature, and when it's hot enough, it will glow and produce light. And then make sure you are able to give the advantages and disadvantages for filament lamps and also fluorescent lamps. And then make sure you generally understand that for electric motors, it changes electrical energy into kinetic energy. All right, so that's the video lesson. The next video lesson, we're going to talk about electric energy and electric power.